So this is CHatlier's principle, and we're going to be dealing with the effects of pressure. So we'll go back to our old friend N2O4 in equilibrium with NO2 gas. And we're going to ask the question, what happens when we increase the pressure of the system? What happens to the N2O4? And so the stress is increasing pressure, and so it wants to decrease the pressure. Now, when we say increasing the pressure, we mean we increase the pressure by changing the volume, PV equal nRT. So if we reduce the volume and leave everything else in yellow constant, then the pressure has to increase. And we're not allowed to change the volume again. We want the equilibrium to shift. So now we think about it again, and now the volume is constant. We've reduced it, and we're keeping it constant now, PV equal nRT. And so our constants are going to be the volume, R, and T. And so the pressure is going to be related to the moles of gas. That's the only way we can decrease the pressure, is decrease the moles. So number 3, decrease the moles of gas. It has to be gas. So when we look up here at our reaction, there's 2 NO2 for every single one N2O4. And so they're both gases. So if we take our 2 moles of gas and make it into 1 mole of gas, we've reduced the moles of gas. And so in this case, the reaction shifts to the left in this direction, okay? And we will see the concentration, or the amount of N2O4 will increase, and the amount of NO2 will decrease. That's all there is to this pressure thing. Let's do another one. So here we have another one. H2 gas plus Cl2 gas gives us 2HCl gas. And if we increase the pressure, what happens to the HCl? Well, what we note here is, 1, the stress is increasing the pressure. 2, we want to decrease the pressure. Which way will it shift? And it turns out, in this case, that there's 2 moles of HCl here, 1 mole of Cl2, and 1 mole of H2. And so on each side of this, we have 2 moles of gas here and 2 moles here. So shifting the reaction will not help us. And so nothing's going to change. And so there is no change. It does not shift. Because the total moles, I should put ones in here for you, are equal. 2 over here is equal to 1, and 1 on that side. So you can end up with no changes on these. Let's do one more. So here we're going to, in this reaction, CaCO3 solid yields CaO solid and CO2 gas. And so in this reaction, we're going to decrease the pressure. What happens to the amount of CaO? Okay, so the stress is decreasing the pressure. Number 2, it wants to increase the pressure. Number 3, we do this by increasing the moles of gas. And so we look at the moles of gas, and really we only have 1 mole of gas. These are not gases. Be careful. You might have tried to think and count these as 1 mole here, 1 here, and 1 here, but that's not right. There's only 1 mole of gas, and it's CO2. That's the only gas. And so to make more gas, we will go in this direction. So 4, we shift right, shift towards the products, and thus we will make more CaO. That's it for these. Practice some of the homework and the worksheets.